everyone, welcome back. Starting from today, we got to learn how going to name different chemical compounds. And based on their name, we're going to know their chemical formulas. That is kind of the key part for the whole high school chemistry. All right, like we learned before, there are three major types of elements in the nature: metal, non-metal, and the metalloids. Metalloids, which is kind of represent the frontier of technology. For example, Silicon Valley, semiconductor. And what we really care about are metal and the non-metals for high school level chemistry. For metals, metals tend to lose electrons, which is going to form cation. And the non-metals tend to gain electrons to turn into ions. Ionic compounds, like we showed before, are combined of both these kind of things, cations and ions. The whole chemical formula charge for an ionic compound is going to be neutral, which is 0, right? Which carry the equal amount of cations and ions. The very common ionic compound we got to deal with or we consume in the daily life are table salts, which is sodium chloride, which has a sodium ion and chloride. Monoatomic ion consists only one element, an atom, for the whole thing. So cations for metals tend to lose electrons to form cation. The number of electrons these metals are going to lose depends on the main group number. So for example, main group 1A element going to lose 1 electron. For the group 2A, going to lose 2 electrons. For the group 3A, going to lose 3 electrons. So let's take a look at here. For the main group 1A, the number of electrons going to lose are only 1 because that's the main group 1. Same kind of thing here for main group 2, number of electrons to lose are 2. And same kind of thing here for main group 3A. All right. If only 1 electron going to lose, and if 1 electron going to lose, and then we label it +1 or just plus. So for example here, lithium, sodium, potassium, rubidium, and cesium, we're going to label it plus. For main group 2A, we labeled 2 plus. Why? Because 2 electrons got lost. For example, ruthenium, magnesium, calcium, selenium, and then barium. For the main group 3A, since 3 electrons got lost, and then we labeled 3 plus, which is aluminum 3 plus. That is going to show us first, those are cations, and the second is that's going to show us how many electrons got lost. So for the main group 1A, 2A, and 3A, those are only metals, all right? However, for group 5A, 6A, and 7A, those are for non-metals. Like I showed before, for non-metals, these elements going to tend to gain electrons, which is going to turn from neutral to negative, which is the ions. And the number of these ions going to gain depends on the number of the main group, which is using the H subtracting the main group number. So for example, let's take a look at here. Fluorine. Fluorine is a non-metal element in the main group 7A. The number of electrons going to gain equals 8 minus 7 equals 1. Why? Because the main group number for fluorine is in the 7A group. So same kind of thing here for fluorine, minus 1. For oxygen and sulfur, because these two are in the main group 6A, so the number of electrons going to gain are equal to 8 minus 6, which is the 2 minus. So let's go back to take a look at here. So for example, for main group 5A, the number of electrons going to gain are equals to 8 minus 5, which is 3 minus. So for main group 6A, the number of electrons going to gain equals 8 minus 6, which is 2 minus. Same kind of thing here for 7A. How are we going to recognize that? Because we label it as the 3 minus, 2 minus, and 3 minus. There are 2 significance behind here is the first one is going to show you these are ions because it's the negative charge carrier. And the second is this number going to show us the number of these kind of electrons going to gain, which is turned from the neutral to negative. All right. So which I want to point out here is the charge are kind of important. And the second is we are going to find out is either cations or anions, because these are going to help us to name chemical compounds. That is going to show us the negative charge have to combine. In total, give a neutral charge. So for metal and non-metal, for the most kind of situation, they only going to depend on the main group number. However, the only one unique situation I want to point out here is for the transition metal. The reason is transition metal is not fit into the main group number. So sometimes for transition metal, the number of electrons going to lose can depend on each kind of situation. For high school students like us, the only kind of thing I want to point out here is iron. Because iron is able to lose either 2 or 3 electrons. If 2 electrons lost, we label it iron 2 plus, and we call it ferrous iron. If 3 electrons lost, and we name it ferric iron, which is iron 3 plus. That is kind of very unique situation here for transition metal. For copper, it can also happen for either 1 or 2 electrons lost. If 2 electrons lost, we call it cuprous iron. If only 1 electron lost, we just call it copper ion. All right. So that is for transition metal. For monoatomic ion, like we talked about that before, we just name it based on the periodic table. However, for polyatomic ion, which is combined of more than 1 atoms, we get to memorize their special and unique name. So for example, let's take a look at here. For cyanide ion, which are combined of 2 atoms, which is copper and nitrogen. And the overall charge for cyanide ion, which is -1. For hydroxide ion, which is combined of oxygen and hydrogen ion, there are 2 elements among that. So the same kind of situation applied for the rest. For example, ammonium cation, which are nitrogen and hydrogen combined together. Sulfate, which is sulfur and oxygen combined together. Chromate, chromium, and oxygen. For high school students, and even for like a college, freshman level college students, those 7 polyatomic ion is fairly enough for us to learn and memorize. We get to memorize not only their name and also their charges, because those going to help us to name these molecular compound in the next. And this chart is kind of important to show us how many of each get to needed for give a neutral charge turn into a 0. All right. So this table is kind of important here to show us the name and the charges. We got to memorize the whole thing. All right, and then let's take a look at each individual example to show us how we're going to apply just we kind of learn here. Binary ionic compound, that is kind of very fundamental and fundamental step we're going to start from. So binary ionic compound composed of only 2 elements, metal and non-metal. And we gotta make sure the overall charge for binary compound has to be 0. So let's take a look at example here. Copper 2 sulfate. All right. So how are we going to convert the phrase into like a chemical formula? We always kind of start from the cation part, which is the metal part, and then we apply that to the sulfide, which is the non-metal part. So here please remember that we always start from metal, and then we go back to the non-metal. All right. So let's take a look at the example here. The first one, copper 2 sulfide. Like I showed you here, we start from the metal part, which is the copper. So, like this, we have to write down the chemical formula for copper. Because that is the copper 2, which tells us that is a 2 plus, right? Which is kind of the 2 character charge. Sulfate, all right. The sulfate, which represents the sulfur, right? And the sulfide, like I showed you guys, because that is in the main group 6A, so the charge for sulfide is going to be 2 minus. All right. So let's take a look at here. Like I showed you guys before, the overall charge for these cation and anion gets to be 0. So in this example here, because 2 plus and 2 minus, and we add these 2 together give us a 0. All right. So which means we only need only one of each of these steps. That gives us a neutral charge of 0. So the chemical formula for copper 2 sulfide going to be copper and sulfur. And let's take a look at the second example, potassium nitrate. Let's start from the metal part, which is the potassium. Because potassium is in the group 1A, right? So the chemical charge, or let's say the chemical charge for potassium is going to be positive, which is potassium positive. Nitrate is in the main group 5A. So the chemical charge for nitrate is going to be 3 minus, right? The reason behind here is 8 minus 5A gave us 3 minus, right? So the chemical charge for nitrite here is 3 minus. So in order this to give us the overall charge to be 0, so think about this. How many potassium we got to put here to give us a neutral charge overall? So how many we can put here, guys? So think about this, which has to be 3, right? Because it's 3 times positive 1, and then we plus minus 3 give us 0, correct? All right, so if there are 3 potassium ion and 1 nitrate ion, and then we combine this, that is the chemical formula for potassium nitrate. All right. So any question here about potassium nitrate? Because that one we have to do a little bit more math based on the chemical formula. So make sure we start with metal and then we combine it with non-metal. But we got to make sure the overall charge has to be 0. That is kind of key part here. So the two things I want to point out here is the first we got to know the chemical formula, right? Their name. And the second is we got to know the charges for each individual, either metal or non-metal. So that is for the binary ionic compound. And also we have to talk about some practice for binary molecular compound. So binary molecular compound are combined with both non-metal. But the general idea, same kind of thing here, is kind of same here. All right, make sure the overall charge got to be 0. Okay, and then this time we can do things reversibly. We give you the chemical formula, and then we get to convert back into the kind of like the English vocabulary, the phrases. All right. So first, make sure we're going to find out that it's kind of a binary ionic compound. So we place the cation name first, and then followed by the ion name, which means we always put the metal first and non-metal right after that. All right. And if the metal element in the binary ionic compound got more than one common ionic charge, we have to use a Roman numeral number to put after the cation name. That is kind of mainly applied to either iron or sulfur. That will be fairly enough for high school students like us. So let's do some example here. All right, so let's do the first example. So cobalt iodide. So think about this, guys. First, we got to make sure that has to be the binary ionic compound. That is kind of very easy to tell because why? They are combined with metal and non-metal. Cobalt are metal and the iodide are non-metal. All right. So like we showed here, we always place the cation name first. So in that kind of example here, cation, which is the cobalt. So we put the cobalt at the beginning. All right. So we put the cobalt at the beginning. Since there are 2 iodide, all right, we put the cobalt iodide. That is a very straightforward and a very fundamental example, which means we always put the metal in the first place, and then we put the non-metal right after that. So that is kind of for the binary ionic compound. So let's do the second example here, lithium selenium. All right, so we always put the metal first, so let's put the lithium at the beginning. And the selenium, we put it right after that. All right, so that is kind of very straightforward example. These 2 examples are pretty straightforward. What I want to mention here is make sure you always put the metal name at the beginning and the non-metal right after that. All right. And we got to show you the example for iron right in the next couple slides. All right. So in the previous slide, to show you the binary ionic compound, that is kind of for the only monoatomic ion. And in this slide, we got to work with some polyatomic ion. Like we showed before, polyatomic ion, we got to regard that as a group, kind of like a family together, so we can never separate this kind of thing. All right, so for polyatomic ion, make sure those number, you give the number for the cation first. It's kind of same kind of thing for binary ionic compound. And then followed by the symbol for the ion. Make sure you add subscripts to balance the charges. All right, it's kind of very similar for how you're going to name binary ionic compound. Make sure two things. The first is you name it correctly, and then make sure the overall charge give you the neutral charge turning to be a 0. And sometimes we need more than one polyatomic ion to balance the charge. And in that kind of situation, we have to put a parenthesis. All right, so let's take a look at example here, magnesium hydroxide. All right, so like kind of shown here, we always put a metal at the beginning and a polyatomic ion right after that. So magnesium, we just do magnesium. Hydroxide, which is OH. The major part, or let's say the key part here, is we got to make sure the charges give you overall equals to 0. All right, hydroxide, which is a -1 charge, and the magnesium here is the 2+. All right, so in order these two give us the neutral charge turning to be a 0, so think about this. How many hydroxide ion we need here? We need 2, right? Because 2 plus -1 times 2 give you 0, correct? So that means we have to put 2 hydroxide ion here. So that is for the first example, magnesium hydroxide. So there are two kind of things here. Name and also make sure the charges here are correctly. So that is why I require you guys to memorize these charges for these either monoatomic or polyatomic ion. So let's take a look at second example, potassium sulfate. All right, so let's start from the potassium, which is the letter K, correctly? The charge for potassium is +1. And sulfate, which is from the previous slide, the sulfate, which is S oxygen 4. All right, so think about this. The positive charge for potassium and the charge for sulfate, which is -2. So in order these two combine together, add up together, give you a neutral charge, which is 0. So think about this. How many potassium ion we can put here? We need 2, correct? Because we use +1 times 2 and a -2, that give you 0, right? So we got to make sure you add correctly the subscripts, give you 0. So that is for the polyatomic ion. And there are some other examples here. So just make sure you have the name correctly, and then make sure the number these charges combined together give you the 0. However, another thing I want to mention here is, in order to show the number in the chemical formula, we got to use some prefix, or let's say the prefix to show the number. So for example, if there is only 1, we call it mono. If there are 2, we call it di, and 3 for tri, and tetra for 4. So we also got to memorize these numbers. That is not only for high school students, even in the college we have to memorize these prefix. That is going to show how many numbers of these atoms shown in the chemical formula. And the last thing I want to mention here in this topic is, so make sure you always name the elements in the order in the formula, which is from the left to the right, from the metal to the non-metal. And another thing I want to mention here is, for the most part, we got to make sure the second elements, you put a suffix, which is the IDE. All right, so make, for example, the oxide, sulfide. So make sure we have in the order, and make sure you give the sulfide.